In the 1950s, the military aviation development program in the United States was centered on the pursuit of faster, higher, and more advanced as the Cold War intensified. Streamlined supersonic interceptors, bombers, and fighters were the norm as we endeavored to maintain a competitive edge over the communists. It may appear peculiar that a short, unattractive, non-supersonic airplane, which was created by raising an existing airframe, became the much-loved and frequently used workhorse in America's strike aircraft arsenal as the Vietnam conflict transitioned from a war by proxy in the late 1950s to an American boots-on-the-ground conflagration beginning in 1965. The Vought A-7 Corsair II was the aviation equivalent of a utility player in sports, not only in the airspace over Vietnam but also for 25 years later. It was capable of performing a variety of tasks successfully, was exceedingly dependable, and altered the nature of the game. When the first A-7s were used in Vietnam, they provided the Navy's carriers with an immediate boost in striking power, and they remained the big ship's standard light attack weapon far longer than could have been predicted. The Corsair II's first Vietnam missions introduced a new generation of navigation and attack avionics to the battlefield. Though these aids have been superseded, the airframe's soundness has been recognized and rewarded by technical updates ever since and is still in service. 854 of the 1,500 A-7s built took part in the Vietnam conflict. They flew over 97,000 sorties in the Southeast Asian theater. Those missions were designed to deliver precise results. Where a B-52 would pulverize broad acreage, the A-7 would come in low to attack a specific target. The Navy flew them in Vietnam with 27 squadrons. 54 A-7s were lost to enemy fire in those 97,000 Navy missions. The losses were higher with earlier models because as weapons accuracy increased, so did the number of single-pass attacks. Still, the nature of the missions at valuable, well-defended targets made them highly dangerous. Relatively slow, low-level attacks invited retaliation. North Vietnam retaliated vigorously. So the losses were not excessive and the returns in terms of strike accuracy were very impressive. One of the most famous actions involving the A-7 Corsair II in Vietnam was the successful attack on the Thanh Hoa Bridge, also known to American pilots as the Dragon's Jaw. This massive structure, located about 70 miles south of Hanoi, had been a key transportation link for the North Vietnamese carrying rail and road traffic over the Song Ma River. It had been bombed repeatedly since 1965 by U.S. aircraft F-105, Thunder Chiefs, A-4 Skyhawks, and even F-4 Phantoms, but the bridge had proven remarkably resilient. Multiple attacks had failed to bring it down completely, in part because of its heavy construction and in part due to the intense anti-aircraft defenses surrounding it. By 1972, the A-7C Corsair II had entered service with the Navy's carrier air wings, bringing with it a new generation of precision-guided weapons. On October 6 of that year, 4 A-7Cs from Attack Squadron VA-82 were assigned to strike the Thanh Hoa Bridge. Two of the Corsairs carried AGM-62 Wall-eyed Sadu glide bombs, each weighing about 2,000 pounds, while the other two aircraft were armed with conventional 2,000-pound MiG-84 general-purpose bombs. Approaching the heavily defended target, the A-7 pilots employed careful tactics to minimize their exposure to enemy anti-aircraft fire. The Walleye-equipped aircraft released their weapons from a safe standoff distance, using television guidance to steer the bombs precisely into the bridge's main structural supports. One of the bridge spans collapsed into the river, severing the vital link for North Vietnamese logistics. The Thanh Hoa Bridge, which had withstood 7 years of bombing attempts, was finally rendered unusable as a transportation route. The A-7 also played an important role in the mining of Haiphong Harbor, North Vietnam's principal port, during an operation codenamed Pocket Money. By the spring of 1972, the North Vietnamese had launched the Easter Offensive, a large-scale conventional invasion of South Vietnam. In response, the United States sought to cut off the enemy supply lines from overseas, most of which entered through Haiphong. On May 9, 1972, aircraft from the carriers USS Coral Sea, USS Kitty Hawk, and USS Constellation executed the mining mission. Navy A-7Es were among the lead aircraft assigned to lay mines in the harbor approaches. Flying at low altitude to ensure precise placement, they dropped special aerial mines timed to activate several days later, giving neutral shipping time to depart. The mining effectively closed Haiphong Harbor to maritime traffic, forcing the North Vietnamese to rely on overland supply routes from China, which were less efficient and more vulnerable to U.S. air attack. Following the Easter Offensive, the U.S. launched Operation Linebacker I, a sustained aerial interdiction campaign aimed at halting the flow of supplies and reinforcements to North Vietnamese forces. The operation began in May 1972 and marked the first large-scale, unrestricted bombing of North Vietnam since the halt of Operation Rolling Thunder in 1968. The A-7 Corsair II was a central player in this campaign. Its advanced navigation and weapon delivery system, unusual for single-seat attack aircraft of the time, allowed it to hit bridges, power plants, rail yards, and other strategic targets with high accuracy. Unlike older attack aircraft, which often required multiple passes to ensure a hit, the A-7 could often achieve the desired effect in a single attack run, reducing exposure to anti-aircraft fire. The combination of precision and endurance meant that Corsair II pilots could carry out deep strike missions into heavily defended areas and still return with enough fuel to operate safely from carriers stationed far offshore. During Linebacker I, A-7 squadrons from multiple carriers conducted both day and night strikes. The aircraft's reliability and accuracy contributed significantly to the destruction of North Vietnam's transportation network, which in turn slowed the enemy's ability to sustain its offensive in the south. If Linebacker I had been about cutting supply lines, Operation Linebacker II, sometimes referred to as the Christmas bombing, was intended to bring North Vietnam back to the negotiating table. Conducted from December 18 to December 29, 1972, this intensive bombing campaign focused on targets in and around Hanoi and Haiphong. While the strategic bombing effort was led by B-52 Stratofortresses, the A-7 Corsair II played a key supporting role. Navy and Air Force A-7s struck air defense sites, supply depots, and transportation hubs, helping to suppress enemy surface-to-air missile batteries and anti-aircraft artillery positions. This suppression was crucial for increasing the survivability of the slower, less maneuverable B-52s. The ability of the A-7 to deliver accurate strikes under heavy fire was once again a major asset. Its missions during Linebacker II further cemented its reputation as a dependable precision strike aircraft capable of operating in high-threat environments. Beyond strategic bombing and interdiction, the A-7 also participated in hazardous search and rescue missions. One of the most remarkable of these took place on November 18, 1972, when an F-105 Thunder Chief pilot was shot down near Tan Hoa. The area was heavily defended, and rescuing a downed airman there required sustained air cover to suppress enemy fire and protect rescue helicopters. Lieutenant Colonel Colin Clark of the U.S. Air Force, flying an A-7D from the 354th Tactical Fighter Wing, took part in the mission. Over 8.8 hours, an exceptionally long duration for a tactical jet, Clark and his fellow pilots repeatedly attacked anti-aircraft positions, often under intense fire, to allow the rescue to proceed. For his actions that day, Clark was awarded the Air Force Cross, one of the nation's highest honors for valor. His A-7D tail number 700970 is now on display at the National Museum of the United States Air Force in Dayton, Ohio. Although the Vietnam War officially ended for the United States in January 1973 with the signing of the Paris Peace Accords, the A-7 Corsair II would see combat again in Southeast Asia in 1975 during the Mayaguez incident.
When Cambodian Khmer Rouge forces seized the American merchant ship SS Mayaguez in May 1975, U.S. forces launched a rescue operation. A-7Es from the USS Coral Sea and A-70s from Korat Royal Thai Air Base provided close air support for the Marines conducting the assault. They struck enemy positions on Koh Tang Island and along the Cambodian coast, helping to suppress hostile fire during the rescue attempt. This operation is often considered the final combat action of the Vietnam War era for U.S. forces. Over the course of its Vietnam service, the A-7 Corsair II built a reputation for both effectiveness and survivability. U.S. Air Force A-7Ds flew 12,928 sorties with only 6 combat losses, a remarkably low rate given the intensity of North Vietnam's air defenses. The aircraft's combination of precision strike capability, range, and reliability meant it could deliver significant firepower while minimizing exposure to enemy fire. Navy A-7Es were similarly successful executing high-risk missions from carriers in the Gulf of Tonkin with relatively low loss rates compared to other aircraft types. For many veterans, the A-7 is remembered not only for its capabilities but also for its dependability. It was not the fastest or most glamorous jet of its era, but it consistently did what was asked of it, often under the most difficult conditions. In that sense, it earned a place alongside the other great workhorses of U.S. military aviation history. In the mid-20th century, the landscape of military aviation was undergoing a revolution. The advent of the jet engine, coupled with technological breakthroughs from World War II, spurred an era of unprecedented progress. Aircraft became faster, more complex, and more capable with increasingly powerful engines and sophisticated airframes. The burgeoning field of avionics in particular fundamentally transformed how combat aircraft were operated and the missions they could perform. This rapid pace of innovation, however, meant that the service life of any given aircraft was remarkably short. A design could be verging on obsolescence by the time it was fully deployed. When hostilities escalated in Vietnam, the United States Navy found its carrier-based attack fleet in such a period of transition. The primary light attack aircraft at the time was the Douglas A-4 Skyhawk, a compact single-seat jet that entered service in 1956. The Skyhawk was celebrated for its simplicity, agility, and cost-effectiveness. It performed its duties with accuracy, but its inherent design limitations in payload and range signaled that a more capable successor would soon be required. While the Skyhawk would go on to serve admirably in the conflict, the Navy was already looking toward the future. This need for a new aircraft was set against the backdrop of the Vought company's own unique history. Vought had established a reputation for embracing unconventional yet effective designs, most famously with the F-4U Corsair of World War II. After a series of post-war jet designs with mixed success, the company solidified its standing with the F-8 Crusader. Entering service in 1955, the Crusader was a marvel of aeronautical engineering and the Navy's first operational fighter to exceed 1,000 miles per hour. It was a highly innovative aircraft incorporating concepts like the area rule for transonic drag reduction and most notably a variable incidence wing. This unique feature allowed the entire wing to pivot upwards for takeoff and landing, providing the high lift needed for slow-speed carrier operations without compromising the wing's sweep for high-speed performance. This solved a critical problem for carrier jets, allowing pilots a level, clear view on approach. The Crusader was a resounding success, a superb dogfighter that earned the moniker the last of the gunfighters and remained in production for nearly a decade. Vought's attempt to evolve this successful design into a next-generation all-weather interceptor, the F-8U-3 Crusader III, proved to be a technical triumph but a commercial failure. Despite its incredible performance, it lost out to McDonnell's F-4 Phantom II, as the Navy's doctrine had shifted to favor two-seat twin-engine aircraft. This contract loss in 1958 was a severe blow to Vought, threatening the company's future as production work on the F-8 line was scheduled to end. It was in this precarious position that Vought turned its attention to the Navy's next major requirement, a replacement for the A-4 Skyhawk. On May 17, 1963, the U.S. Navy issued its formal specifications for a new carrier-based light attack aircraft, a program designated VL Vought Attack Light. The requirements were demanding and reflected the lessons being learned in the early stages of the Vietnam conflict. The new aircraft needed to carry a payload and fly a combat radius roughly double that of the A-4 Skyhawk it was intended to replace. This emphasis on range and load carrying capacity was paramount. Significantly, the Navy made two pragmatic stipulations that would fundamentally shape the resulting aircraft. First, to expedite development, reduce costs, and minimize technical risk, all proposals were required to be based on an existing proven aircraft design. Second, the Navy consciously omitted a requirement for supersonic speed. Studies had concluded that for the ground attack and close air support roles, the added weight, complexity, and expense of a supersonic airframe and engine would not yield a proportional increase in mission effectiveness or survivability. The new attack plane would be subsonic, a decision that prioritized endurance, payload, and operational economy over raw speed. For the engineering team at Vought, led by the distinguished designer John Russell Clark, who had also helmed the F-8 Crusader project, the path forward was clear. The proven Crusader airframe was the logical starting point. Vaught's proposal, built around a modified F-8, was declared the winner of the competition on February 11, 1964, beating out designs from Douglas, Grumman, and North American. Although Vaught's submission was based on the F-8, the final design designated the A-7 was far more than a simple modification. While it bore a strong family resemblance to its fighter predecessor, it was for all practical purposes a new aircraft meticulously optimized for the attack mission. The design philosophy was to retain the successful elements of the Crusader while systematically redesigning everything else to meet the VL specifications. The most obvious visual link, the chin air intake below the nose, was kept. This design was highly efficient at subsonic and transonic speeds, providing excellent pressure recovery for the engine with minimal airflow turbulence. However, the fuselage itself was radically altered. It was made shorter, wider, and distinctly more portly than the Crusader's sleek supersonic form. This new, more voluminous fuselage accommodated a significantly larger internal fuel load, a key factor in meeting the Navy's demanding range requirements as well as housing the advanced new avionics systems. The most critical departure from the F-8 was the wing. The Crusader's complex and heavy variable incidence mechanism was completely eliminated. For a subsonic attack aircraft, it was an unnecessary complication. In its place, Clark's team designed a new, simpler, non-pivoting wing. This wing, still mounted high on the fuselage to provide ample clearance for ordnance, featured a moderate 35-degree sweep and was equipped with large full-span leading-edge slats and massive trailing-edge flaps. This configuration generated immense lift, giving the A-7 exceptional low-speed handling characteristics and the ability to operate from carrier decks with a heavy war load, albeit at a higher, more nose-up deck attitude than the Crusader. The A-7 was engineered from the ground up to be a premier ordnance delivery platform. It featured 6 underwing pylons and 2 fuselage side pylons, all carefully positioned to minimize impact on the aircraft's center of gravity as stores were released. The A-7A could carry a staggering 15,000 pounds of external stores, a figure that would grow to 20,000 pounds in later variants, a monumental increase over the A-4 Skyhawk. Powering the initial A-7A model was the Pratt & Whitney TF30 P6 turbofan engine. The choice of a turbofan rather than the turbojet used in the F-8 was another deliberate decision aligned with the mission. Turbofans offered vastly superior fuel efficiency at subsonic speeds, directly contributing to the A-7's impressive range and loiter time. While this engine would later be assessed as marginally underpowered for the airframe's weight, it was designed for reliability and ease of maintenance. A four-man team could in theory perform a complete engine change in about 45 minutes, a critical consideration for maintaining high operational tempos aboard an aircraft carrier. Perhaps the most significant advancement was hidden inside the airframe. The A-7 was equipped with a comprehensive and highly advanced avionics suite for its time. This included a multimode radar and inertial navigation system and a Doppler radar, all integrated through a central weapons delivery computer. This system provided the pilot with a continuously computed impact point on a head-up display, allowing for unprecedented accuracy in dive bombing and weapons delivery. This fusion of a stable subsonic airframe with a state-of-the-art targeting system was the core of the A-7's design philosophy and the key to its future success. The A-7 program moved forward at a remarkable pace. The first prototype completed its maiden flight on September 27, 1965, ahead of schedule. The flight test program was exceptionally successful, and the Navy, pleased with the results, placed its first production order. The only significant deviation from the original specification was that the aircraft came in about 600 pounds overweight. A minor discrepancy the Navy willingly accepted given the plane's otherwise stellar performance. The first Navy squadrons began training on the new aircraft, now officially named the Corsair II, in honor of its famous Vought predecessor. Initial carrier qualification trials, however, revealed the design's first major flaw. During catapult launches, steam from the carrier's catapult was ingested by the low-slung chin intake. This steam could disrupt airflow to the TF-30 engine, causing a dangerous compressor stall and loss of thrust at the most critical phase of flight. As an interim solution, takeoff weight was restricted until a more permanent fix could be developed. This engine power issue would cast a shadow over the early A-7A and A-7B models until more powerful engines were introduced. Despite this issue, the escalating war in Vietnam created an urgent need for the Corsair II's capabilities. On December 4, 1967, A-7As from Attack Squadron 147 VA-147, the Argonauts flying from the deck of the USS Ranger, conducted the aircraft's first combat sorties over North Vietnam. The Corsair II was immediately put to the test, flying a variety of demanding missions. These included interdiction strikes against heavily defended targets like bridges and supply depots, armed reconnaissance patrols searching for targets of opportunity along the Ho Chi Minh Trail, and suppression of enemy air defenses missions against surface-to-air missile sites. The A-7's combat debut proved the soundness of its design. Its ability to carry a heavy load of bombs with precision and remain on station for extended periods made it an invaluable asset. Pilots quickly came to appreciate its rugged construction and stable flight characteristics, which made it an excellent platform for accurate weapons delivery. The risks, however, were real. The first A-7 was lost to ground fire on December 22, 1967, just 18 days into its combat career. The A-7 operated as a key component of the Carrier Air Wing's powerful Alpha Strike's large coordinated raids involving dozens of aircraft. In these complex operations, F-4 Phantoms provided fighter cover. A-6 intruders conducted all-weather and night attacks, and the A-7 served as the primary daylight precision bomb trucks, delivering tons of ordnance with pinpoint accuracy. The pilots, who had initially nicknamed the stout aircraft the SLUF, short little ugly fucker, soon found the name becoming a term of endearment, a nod to the plane's unglamorous appearance but deeply respected toughness and reliability. The Corsair II's success did not go unnoticed. In a surprising move, the United States Air Force, which had not procured a new subsonic tactical fighter in over a decade, selected the A-7 as a replacement for its own aging attack aircraft. The supersonic fighters in its inventory, like the F-100 Super Sabre and F-105 Thunder Chief, had proven ill-suited for the close air support role in Vietnam, lacking the necessary payload range and loiter capability. The Air Force, however, was not content with an off-the-shelf Navy plane. They stipulated a series of significant upgrades for their version designated the A-7D. The most important of these was the replacement of the Pratt & Whitney TF-30 engine with the Allison TF-41, a license-built version of the powerful and highly reliable Rolls-Royce Spey turbofan. This new engine finally provided the Corsair II with the thrust it needed, eliminating the underpowered issues of the early models and dramatically improving takeoff and overall performance. Furthermore, the Air Force mandated a vastly superior avionics package. The A-7D was equipped with an advanced digital navigation and weapons delivery computer, a new head-up display, and a projected map display system. The two 20mm Colt cannons of the Navy version were replaced with a single devastatingly effective M61 Vulcan 20mm Gatling gun capable of firing at rates of 4,000 or 6,000 rounds per minute. These enhancements transformed an already excellent aircraft into something truly exceptional. The A-7D's bombing accuracy was phenomenal. The Navy, witnessing the quantum leap in capability of the Air Force's version, quickly ordered its equivalent. This new Navy model, the A-70, incorporated the same powerful TF-41 engine and the sophisticated avionics suite of the A-7D. The A-70 became the definitive version of the Corsair II. It entered the Vietnam conflict in force and quickly became the Navy's premier light attack aircraft, replacing most of the A-4 Skyhawks by 1972. The increased accuracy of the A-70 is widely credited with contributing to a lower loss rate compared to earlier models. Pilots could now confidently place their ordnance on target on the first pass, drastically reducing their exposure time over heavily defended areas. The A-70 models would go on to fly nearly as many combat missions in Vietnam as all other A-7 variants combined, cementing the Corsair II's legacy. Throughout the war, A-7s flew over 90,000 combat sorties, a testament to their durability and importance to the war effort. The final American bomb of the entire conflict was dropped by an Air Force A-7D near Phnom Penh, Cambodia on August 15, 1973. The end of the Vietnam War did not mark the end of the A-7's service. The rugged airframe proved to be remarkably adaptable and long-lived, serving through the interwar years with distinction. Navy and Air Force Corsair IIs saw combat again in the 1980s, flying missions over Grenada, Lebanon, and Libya during the Gulf of Sidra incidents, continually demonstrating their value as a reliable attack platform. Its final and perhaps most poignant combat role came in 1991 during Operation Desert Storm. By this time, the Corsair II was a venerable airframe already in the process of being phased out of the fleet in favor of the newer multi-role FA-18 Hornet. Yet when the call to arms came to liberate Kuwait, the A-70 was once again deemed an essential asset. Two dedicated U.S. Navy attack squadrons, VA-46 Klansman and VA-72 Blue Hawks, deployed aboard the carrier USS John Kennedy to the Persian Gulf. For these squadrons, it would be the Corsair II's last hurrah. Flying alongside a new generation of tactical aircraft, the aging Corsair IIs proved to be exceptionally effective and reliable workhorses. They were tasked with a wide range of critical missions deep inside Iraq and Kuwait, including battlefield air interdiction, striking strategic targets such as airfield supply depots and bridges, and providing close air support for coalition ground forces. The A-7's legendary payload capacity and impressive combat radius, the very characteristics for which it was designed decades earlier, made it an invaluable asset in the fast-paced air campaign. The Corsair II's stability and adaptability as a weapons platform were on full display. In addition to carrying heavy loads of conventional Mk-82 and MiG-84 general-purpose bombs, the A-7Es were notably effective in deploying a variety of precision-guided munitions. They became one of the Navy's primary platforms for the AGM-62 Walleye, a television-guided glide bomb that allowed pilots to strike hardened targets like reinforced aircraft shelters and bridges with pinpoint accuracy from a standoff distance.
They also flew vital suppression of enemy air defense missions, hunting and destroying Iraqi radar sites with AGM-88 HARM high-speed anti-radiation missile, thereby clearing a safer path for other strike packages. Throughout the 44-day air campaign, the two squadrons demonstrated remarkable combat effectiveness. The A-7s maintained high mission-capable rates, a testament to their robust design and the skill of their maintenance crews. In a stunning tribute to the aircraft's ruggedness and the proficiency of its pilots, not a single A-7 was lost to enemy action during the conflict, despite flying hundreds of sorties into a heavily defended environment. For the A-7 Corsair II Operation Desert Storm was a fitting final chapter. It was a last demonstration that saw the old veteran prove its enduring worth on the modern battlefield, validating decades of continuous upgrades and the fundamental soundness of its original design. Shortly after returning from the Gulf, the last Navy A-7 squadrons were disestablished, bringing the aircraft's distinguished three-decade combat career with the U.S. military to a close. Despite its success with the U.S. military, the Corsair II saw limited foreign sales. Only Greece and Portugal opted to fly the aircraft. The Hellenic Air Force purchased 60 new-build A-7H models, essentially A-7Es, without carrier equipment, and later acquired refurbished U.S. Navy A-7Es. The Portuguese Air Force acquired refurbished A-7As, which were upgraded with more powerful engines and modern avionics to a standard designated A-7P. Even as the aircraft was being retired from U.S. service in the 1990s, the soundness of the basic design was so great that it was considered for one final radical upgrade. In the late 1980s, Vought, by then part of LTV, rebuilt two A-7s into a supersonic technology demonstrator known as the A-7F Strike Fighter. By installing a powerful Pratt & Whitney F100 afterburning turbofan, the same engine used in the F-15 and F-16, and adding fuselage extensions, the company created a supersonic Corsair II. While the A-7F demonstrated impressive performance, the program was ultimately cancelled in the post-Cold War defense drawdowns. Nevertheless, the fact that a subsonic airframe from the early 1960s could be successfully modified for supersonic flight was the ultimate tribute to the integrity of Russell Clark's original design. The A-7 Corsair II was never the most glamorous aircraft of its era. It lacked the raw speed of a Phantom or the sleek lines of a Crusader, but it was not designed for glamour, it was designed for a job. As a rugged, reliable, and exceptionally precise weapons delivery platform, it was a masterpiece of pragmatic engineering. It perfectly fulfilled the Navy's requirement for an aircraft that could carry a heavy load, fly a long way, and put bombs on a target with unmatched accuracy, and it did so for nearly 3 decades of dedicated service. Thanks for watching. We would love it if you would give us some feedback on our new voiceover. We recorded it ourselves and edited the original audio. So goodbye and see you in the next videos. Please subscribe to our channel to hear more interesting stories about the planes we find.